The map of the world is temporary. You might think the ground beneath your feet is solid, permanent, and unmoving, but that is a lie. Right now, the planet is physically tearing itself apart. We aren't talking about geological timescales that take millions of years to notice. We are talking about cracks opening up in the ground overnight. In East Africa, a split is widening that will eventually turn one continent into two, creating a brand new ocean where desert stands today. But that is just the visible scar. Deep beneath Europe, a monster is breathing, waking up in a way we haven't seen in centuries. And off the coast of the Americas, the ocean floor is inflating like a balloon, preparing to burst. From the ice of Antarctica to the supervolcanoes of Italy, the Earth is moving, and the scary part isn't that it's happening. The scary part is how fast it's happening. Let's start at the most dramatic wound on the planet, the East African Rift. This isn't just a valley, it's a physical divorce between two massive tectonic plates, the Somali Plate and the Nubian Plate. For decades, scientists treated this as a slow academic curiosity. But recently, the timeline has accelerated. In the deserts of Ethiopia and the rift valleys of Kenya, massive fissures have begun to slice through highways and farmlands. In some cases, these cracks appear in a matter of hours, swallowing livestock and splitting homes in half. This is the Earth's crust literally unzipping. What is happening here is driven by a massive plume of superheated rock rising from the deep mantle, pushing the crust upward and stretching it until it snaps. As these plates pull away from each other, the crust thins, it becomes weak. And when the crust is weak, magma finds a way through. This geological violence is creating a pathway for the Red Sea and the Gulf of Aden to flood into the continent. It's a slow motion catastrophe that is carving out a new world. When that water finally breaks through, it won't be a trickle. It will be the birth of Earth's sixth ocean. East Africa will become a massive island, drifting away from the mainland, forever changing the shape of the globe. We are witnessing the geography of the future being written in real time. While Africa splits, Europe is facing a different kind of threat, one that is hiding in plain sight. Everyone looks at Mount Vesuvius, the famous killer that buried Pompeii. It is dangerous, certainly. It looms over Naples like a ticking time bomb. But it is hiding a much larger, much angrier neighbor just to the west. We're talking about the Campi Flegrei, the burning fields. Unlike Vesuvius, this isn't a mountain you can see. It's a caldera, a massive depression in the ground that stretches for miles, partially underwater. And it is restless. For the last few decades, the ground here hasn't just been shaking, it has been rising. This phenomenon is called bradyseism. It means the caldera is inflating from below. The port town of Pozzuoli has been lifted out of the sea by meters in recent years. This uplift suggests that magma and superheated gases are accumulating just below the surface, looking for a way out. A prehistoric eruption here was strong enough to plunge Europe into a volcanic winter and potentially wipe out the Neanderthals. Today, millions of people live literally inside the crater. The danger here is population density. If Campi Flegrei wakes up, evacuation becomes a logistical nightmare. The question isn't if it will erupt again, but when, and whether we will recognize the signs before it's too late. Across the Atlantic, the threat changes shape again. When people think of American supervolcanoes, they look to Yellowstone. Yellowstone is indeed a beast. Its past eruptions were so massive they blanketed the continent in ash and altered the global climate. If it were to blow today, it would be a civilization-ending event. However, despite the headlines, the magma chamber beneath Yellowstone is currently mostly solid mush. It's sleeping. The real, immediate activity is happening elsewhere. Look at Mount Adams in Washington state. For thousands of years, Mount Adams was the quiet neighbor to the more explosive Mount St. Helens. But recently, seismic monitors have lit up. A sudden spike in earthquakes suggests something is shifting deep in the plumbing of the Cascades. It's a reminder that these mountains are not dead. They are merely dormant. Further south, in Arizona, we find vast volcanic fields that look extinct but are deceptively dangerous. The San Francisco Volcanic Field has exploded more than 600 times. These are what we call monogenetic fields. Unlike a big mountain that erupts over and over, these fields create a new volcano every time they erupt. You don't know where the next one will pop up. It could be in a forest or it could be in a suburb. The heat is still there beneath the desert floor, waiting for a weak spot. But If you want to see where the Earth is most active, you have to look where no one is watching. The bottom of the ocean. Off the coast of Oregon lies the axial seamount. This is an underwater volcano that doesn't just erupt, it follows a schedule. Scientists have wired this seamount with pressure sensors, creating a cabled observatory on the ocean floor. What they are seeing is incredible. The floor of the caldera inflates rapidly, rising by meters as magma fills the reservoir below. Then it deflates instantly when it erupts. It is currently inflating again, signaling that another eruption is imminent. This matters because submarine volcanoes are the engine of our planet's chemistry. They pump heat and minerals into the ocean, fueling bizarre ecosystems that don't rely on the sun. But they also remind us that the planet is constantly reshaping itself in the dark, miles beneath the waves. We are only now getting the technology to see it happen. There is one more place where volcanoes are hiding, and it might be the most dangerous place of all: Antarctica. Beneath the miles-thick ice sheets, scientists have discovered nearly 100 volcanoes. Most are dormant, but not all. Recent studies show active heat sources melting the ice from below. If these subglacial volcanoes erupt, we won't see lava fountains. Instead, the heat will melt the ice, creating vast lakes of lubricated water between the ground and the glacier. This water greases the path for the ice to slide into the ocean. This is a terrifying feedback loop. As the ice melts, the weight on the Earth's crust decreases. This unloading can actually trigger more eruptions, which melts more ice. If the West Antarctic ice sheet slides into the ocean, it could catastrophically accelerate sea level rise, reshaping coastlines from New York to Tokyo. The fire is hidden, but the water it unleashes will come for us all. Why does all of this matter? Why should we care about cracks in Africa or rising ground in Italy? Because we have a habit of forgetting how fragile our civilization is. We build our cities on the skins of sleeping giants, assuming they will never wake up. In 79 CE, the people of Pompeii didn't even know Vesuvius was a volcano. They thought it was just a mountain. When it exploded, it didn't just rain fire. It unleashed pyroclastic flows, avalanches of superheated gas and rock moving at hurricane speeds. It vaporized everything in its path. But the local destruction was just the beginning. History shows us that volcanoes are global killers. Look at the eruption of Mount Tambora in 1815. It was so massive that it blocked out the sun, causing the year without a summer. Snow fell in July in North America. Crops failed across Europe. Famine spread across the globe. Or go back further to the Toba eruption 74,000 years ago. It was a super eruption that plunged the planet into a volcanic winter that lasted years. Genetic studies suggest it may have reduced the human population to just a few thousand survivors. We are the descendants of those few who made it through the ash and the cold. We are not immune. A super eruption today wouldn't just destroy a city. It would ground global aviation, destroy agriculture, crash the global economy, and cool the climate for years. So how does this actually work? What turns a mountain into a monster? It all comes down to viscosity and gas. Think of magma like a bottle of soda. If the magma is runny, like in Hawaii, the gas escapes easily. You get lava flows, destructive but slow. You can walk away from them. But if the magma is thick and sticky, like peanut butter, the gas gets trapped. The pressure builds and builds inside the chamber. It pushes the ground up, causing the earthquakes and uplift we see in Italy and the Americas. When that pressure finally breaks the rock above it, the gas expands instantly. The magma is ripped apart into tiny shards of glass and rock. This is volcanic ash. It's not soft like wood ash. It's jagged rock that destroys engines and lungs. This column of ash can shoot 30 miles into the stratosphere, circling the globe and blocking out the sun. That is the mechanics of a super eruption. It is physics, pressure, and time. And yet, this is the paradox. The very forces that threaten to destroy us are the only reason we are here. Without volcanic outgassing, billions of years ago, Earth would have no atmosphere. We would have no oceans. The water you drink and the air you breathe were once trapped inside burning rock, released by the very eruptions we fear. Volcanoes recycle the carbon that keeps our planet warm enough to sustain life. They create the most fertile soil on Earth, which is why millions of people live near Vesuvius and in Indonesia. We are drawn to them because they give life, even as they threaten to take it away. The splitting of Africa, the breathing of Campi Flegrei, decay, the inflation of the seafloor. This is the heartbeat of a living planet. A dead planet doesn't shake, a dead planet doesn't erupt. Mars is dead, the moon is dead, Earth is alive. The Earth is cracking open, shifting, and changing. It is a terrifying process, but it is also the engine of creation. The challenge for us is not to stop it, we can't, but to understand it, respect it, and be ready when the ground starts to move. The planet is telling us a story if we are brave enough to listen. Which of these geological ticking time bombs do you think poses the biggest threat to our future? Is it the immediate danger of Vesuvius or the slow motion disaster of the Antarctic melt? Let us know in the comments below. And if you want to keep exploring the dangerous beauty of our world, make sure you hit that subscribe button so you don't miss what's coming next. The ground is moving. Don't get left behind.